Hello everyone, welcome back to part 2 of Calculus Prerequisites. So I mentioned that functions was one area that we will need in order to study calculus. Now we'll actually come back to that when we start our first unit in calculus. So for this video, we're going to focus on trigonometry. So being able to convert between radians and degrees, being able to calculate certain trigonometric ratios, either by using the unit circle or with special triangles, being able to use the Pythagorean theorem for right angle triangles, being able to solve equations that involve trig functions, and also being able to use certain identities. So let's have a look at a few examples of converting between degrees and radians and vice versa. So for the first example, we want to convert 300 degrees into radians. And to convert from degrees to radians, we're going to multiply by pi over 180 degrees. Since we want to convert from degrees to radians, what we want is pi to be in the numerator and the degrees to be in the denominator. So we're really multiplying this by 1, right? We know that pi is equal to 180 degrees. And if we were to look at the units, the degrees will cancel with one another. And we're left with pi in the numerator. Okay, so we can simplify this by multiplying our fractions. So we have 300 pi over 180. Okay, so we can simplify this. So we have 30 pi over 18. We know that 10 is divisible by both 300 and 180. So this will be reduced to 30 over 18. And 30 and 18 are both divisible by 6. So we can further reduce this. So 30 over 6 gives us 5, and 18 over 6 gives us 3. So we have 5 over 3 pi radians. So now in the next example, we're going to be converting from radians to degrees. So we have 5 pi over 6 radians. And if we want to convert from radians to degrees, we're going to multiply by 180 degrees over pi. Again, we're multiplying our angle by 1, right? 180 degrees is the same as pi radians. And since we want to convert to radians, or sorry, to degrees, we want to have degrees in the numerator. So now let's simplify our fractions. We know that the pi's will cancel. And 180 divided by 6 is going to be equal to 30. So we have 5 times 30 degrees, which is 150 degrees. In the third example, we're going to look at finding the exact values for certain trig ratios. So in the first example, in example 3, we have the tangent of pi over 3. So here you can use either the unit circle or special triangles to calculate the exact value. So I like to use the special triangles. So let's have a look at the special triangle, which involves the angle of pi over 3. So we have our right angle triangle. The special triangle, which involves pi over 3, or 60 degrees, will be pi over 3. The other angle will be pi over 6. And then we have our right angle, which is 90 degrees. Now, to remember what the lengths of the sides of this special triangle is, I like to look at the smallest angle between pi over 6 and pi over 3. So pi over 6 is the smaller angle. This is equivalent to 30 degrees, and pi over 3 is equivalent to 60 degrees. So the smaller angle, which is pi over 6, across from this angle is the smallest side, which I will use 1 for the smallest side. The hypotenuse is going to be 2, and the third side is root 3. So I like to remember this as 1, hypotenuse is 2, and the third side is root 3. So what we want is to find the tangent of pi over 3. We know that tangent is the ratio of the opposite side over the adjacent side. So from pi over 3, the opposite side is root 3, and the adjacent side is 1. So the tangent of pi over 3 is equal to root 3. Now in part B, we want to find the sine of 7 pi over 6. Okay, so here again we can use special triangles, but we'll also need to use the cast rule. Okay, so let's have a look at what the cast rule is. So if we draw the quadrants, and we're going to label each of the quadrants with a certain letter. In quadrant 4 is going to be C. In quadrant 1 is going to be A. In quadrant 2 is S. And in quadrant 3 is T. So it spells cast if we start in quadrant 4 and label each quadrant with the letter that spells cast, going counterclockwise. So the cast rule will tell us what the sine of each trig ratio is. So for example, in quadrant 1, so A says that all of the trig ratios are going to be positive in that quadrant. In quadrant 2, which is labeled with S, this will tell us that sine is going to be positive in this quadrant. And then the quadrant labeled with T tells us that tangent will be positive, and then the quadrant labeled with C is telling us that cosine is going to be positive in this quadrant. So now let's also label the angles. So here we start measuring the angle 0 between quadrant 4 and quadrant 1, then between quadrant 1 and quadrant 2, this is pi over 2, or 90 degrees, and then we have pi, or 180 degrees, then 3 pi over 2, and then we're back to 2 pi, which is the same as 0 degrees. So what we're wanting to find is the sine of 7 pi over 6. So 7 pi over 6 is just a bit larger than pi, right? It's pi over 6 more than pi. So that angle is going to be in quadrant 3. So this entire angle is 7 pi over 6. Okay, so pi is the same as 6 pi over 6. And so the angle in this triangle in quadrant 3 this particular angle measured from the x-axis is going to be pi over 6. So this is sometimes called the reference angle. So the special triangle that we're going to use is going to be the pi over 6 and pi over 3 triangle. So across from pi over 6, we know that that angle is the smallest side, which is going to be 1. So this vertical side of the triangle is going to have a length of -1 because we're in the bottom quadrants. Okay, so now the hypotenuse is always positive, so that will be equal to 2, and the third side is going to be √3. Okay, and because we're in the third quadrant, we know that this length is going to be -√3. So now we can determine what the sine of 7 pi over 6 is. So sine is opposite over hypotenuse. Okay, sine is opposite over hypotenuse. The opposite side is -1, and the hypotenuse is equal to 2. So the sine of 7 pi over 6 is going to be -1/2. Okay, so now we'll look at solving equations that involve trig. Oops. So here we have the equation sine of theta is equal to 1/2, and the angle theta is between 0 and 2 pi. So this equation can have more than one solution. So we're also going to need our special triangles and the cast rule to solve for the angles of theta. The first thing that we'll need is to determine the reference angle. So we want to draw out the special triangle. So let's suppose that this angle is theta. This is the angle that we're looking for. Now we want the sine of theta to be 1/2. So the opposite side is going to be 1. The hypotenuse is going to be 2. Now from our special triangles, we know that the third side is going to be √3. And for this special triangle, we know that the angle that is opposite from the smallest side is going to be pi over 6. So the reference angle is going to be pi over 6. Then the other angle is pi over 3. So now that we have our reference angle, let's use the cast rule to determine the angles between 0 and 2 pi, which gives us a sine of the angle equal to +1/2. So cast rule tells us where each of the trig ratios are going to be positive. We want the sine of theta to be positive, so we're either in quadrant 1 or quadrant 2 using the cast rule. So now we're going to draw the reference angle in both of these quadrants. The reference angle is the angle between the x-axis. So here we have pi over 6 in quadrant 1, and in quadrant 2, this angle will also be pi over 6. So the two angles that we want to determine is the one in quadrant 1 as well as the one in quadrant 2. So let's also label the other angles at each of the axes. We have 0, pi over 2, pi, and 3 pi over 2. So our first angle is going to be from quadrant 1, which is pi over 6. The second angle is going to be pi over 6 less than pi. Okay, so we want the entire angle from 0 to the angle in quadrant 2, which will be pi minus pi over 6. And this is 6 pi over 6 minus pi over 6, which will be 5 pi over 6. So this entire angle is going to be 5 pi over 6. Okay, so the two angles are either pi over 6 and 5 pi over 6. So now let's have a look at another example. So suppose we want to find the angles for which tangent of theta is equal to -1. So now to solve this equation, we need to look at the other special triangle. So the tangent of theta is going to be equal to 1. We know that the tangent is the ratio of the opposite side and the adjacent side. So if the tangent of the angle is equal to 1, this tells us that the opposite and the adjacent side are equal. So we'll label both of these 1. Then we can solve for the hypotenuse by using Pythagorean's theorem. So using Pythagorean's theorem, the hypotenuse is going to be root 2. And this is an isosceles triangle. So both of the angles are going to be equal, which is 45 degrees or pi over 4. So now since we want the tangent of theta to be equal to 1, well, it's going to be equal to -1. However, what we want to look for is the reference angle. And so the triangle that is used to determine the reference angle is going to be the pi over 4 special triangle. So this tells us that the reference angle is going to be pi over 4. So now that we have the reference angle, we can then use the cast rule to determine when tangent is equal to -1. Oops. Okay, so we know that tangent is going to be positive in quadrant 1 and quadrant 3, which means that tangent is negative in quadrants 2 and in quadrants 4. So let's draw the triangle in quadrants 2. So the reference angle is pi over 4. That will be this angle here. And again, we also have a triangle in quadrant 4. And this angle between the x-axis is going to be pi over 4. So now what we need to determine is the angle measured from 0 that corresponds to these two triangles. Okay, so we have the angle 0, pi over 2, pi, and 3 pi over 2. So the angle in quadrant 2 is going to be pi over 4 less than pi. So pi minus pi over 4 gives us 4 pi over 4 minus pi over 4, which is 3 pi over 4. So that is one of our angles. And the other angle is going to be 2 pi minus pi over 4. So it's going to be this entire angle, which is 2 pi minus pi over 4. So 8 pi over 4 minus pi over 4 gives us 7 pi over 4. So the solutions to our equation is going to be 3 pi over 4 and 7 pi over 4. So now let's have a look at one more example for solving certain equations with trig functions. So here we want to find all angles of theta that satisfies the equation, where theta is between 0 and 2 pi. So our equation is cos squared of theta minus sine squared of theta is equal to 0. So there are many different ways to actually solve for the angles of theta, and here is just one way. So I've listed some identities that can be useful for us. These are called the double angle formulas. And so the one that we'll be using is going to be the cos of 2x double angle formula. This is equal to cos squared of x minus sine squared of x. And we see on the left-hand side, that is exactly what we have, but we're using the angle theta as our variable. So let's have a look at solving the equation by using our identity. So we have cosine squared of theta minus sine squared of theta is equal to 0. So we use the double angle identity. The left-hand side is equal to the cos of 2 theta equal to 0. So we want to find the angles where cos of 2 theta is equal to 0, where theta is between 0 and 2 pi. So we know that the cos of the angle, we'll call it x, is going to be 0 if the angle x is some integer multiple of pi plus pi over 2. Okay, so n is an integer, and we're going to use the symbol z to denote the set of integers. And so if the argument of cosine is n pi plus pi over 2, where n is some integer, then this will tell us that the cos of x will be equal to 0. So now we're going to apply this to our equation. So in this case, our x is going to be 2 theta. So the cos of 2 theta will be 0 if 2 theta is n pi plus pi over 2, where n is an integer. So now we can solve this equation for theta. So if we divide both sides by 2, we get n pi over 2 plus n pi over 2 divided by 2, which gives us n pi over 4, where n is some integer. So now we need to determine what the angles are, which are going to be between 0 and 2 pi. So the first angle that we'll get is obtained if we let n equal 0. Okay, so if n equals 0, then theta is going to be 0 times pi over 2 plus pi over 4, which is pi over 4. So we're going to let n be equal to 1 to find the next angle. So theta is going to be 1 times pi over 2 plus pi over 4. This will be 3 pi over 4 if you use a common denominator of 4. For the next angle, let's let n equal 2. We get 2 pi over 2 plus pi over 4. This will give us 5 pi over 4. Again, you want to use a common denominator of 4. The next angle is when n is equal to 3. So we'll get 3 pi over 2 plus pi over 4, which gives us 7 pi over 4. So now if you try to let n equals 4, then we'll get 4 pi over 2 plus pi over 4, which will be 9 pi over 4. However, this angle is outside of 2 pi. So this will give us just 4 solutions, which will be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4.